Okay, so thank you for the introduction. And I'm Gabriele. You can call me just by that name if you wish to make a question at the end. And I'll give that speech that is Training the Metaverse, a journey into learning with immersive media, which is based on a very little subset of my research works that I carried out through the path of education and training with extended reality. So I don't know your background. Maybe you are hardcore electronic and computer engineering. I don't know which are from which you were background. So I will give a common lay for everyone. So we call XR as extended reality. Is an umbrella term that refers to two main kinds of immersive media, which are the family of virtual reality and augmented and mixed reality. So I will start by talking about augmented reality, since it's maybe the one that you are mostly familiar with, since in their basic form can be provided through simple tablet and smartphone devices. So in that case, augmented reality means that you have digital content overlaid on top of the real world, and with such devices you do that by the video camera feed. But there are other ways to provide, of course, this kind of medium. For instance, you can do for spatial augmented reality, in which you directly project the digital content on top of the real world, and of course you can add-on the fancy headset, and that are usually based on some kind of lightweight technology with semi-transparent displays that allows the user to see both the real world and the digital world. If you are wondering why some people are calling it mixed reality, other people augmented reality, in the field you usually refer to augmented reality as something that is just overlaid but with no context with the real world. Instead, with mixed reality we think that the digital content, the computer-generated content, are fully in context and blended with the real world. Okay. Getting higher in the level of immersion that we can go to the virtual reality side. Formerly, the only way was to use special rooms with all the walls with projection, very costly, and we talk about 300K euros to build a room such that. Nowadays, thanks to your colleagues' job, we are able to access the virtual reality through very affordable devices. I will mostly focus on virtual reality in that speech, so I will give a bit dive into a list of what can be done with the headsets. So I don't know if any of you have experienced the virtual reality by yourself, and for those of you who have not, I usually use that quote, because talking about VR is really like dancing about architecture. You cannot have an idea of what it means to be fully immersed, to have your senses fully deceived by a simulated environment if you have not tried yet. So if some of you is interested, we are always welcome to get participants for our study in the other side of the of the building. But of course, not all the headsets are made equal, and we can have a more cheaper and affordable headset with lower capabilities, and on the other side of the spectrum, the opposite. Usually we set the bar for what is acceptable for a true immersive VR experience there. So to have at least an headset which is capable to allows the user not only to move your head around, but also to wander in the real world, ergo virtual environment, and have your hands tracked in some way, either by using conventional controllers or more sophisticated and tracking technology. And by doing so, of course, you can build a lot of different experiences, not only pertaining only to training, but we will focus on that. And why is it important to have also and other stuff? Because what you see in virtual reality is actually not the whole story. It's maybe the least significant part of the story. Sounds counts a lot, and interaction is key in virtual reality. So what you see is not all the stuff. So just to have a brief, let's say, picture of what has been already demonstrated, what are the pros of using extended reality for training. Of course, it allows to train people on hazardous or dangerous tasks that will be incredibly costly or impractical to replicate for real. Imagine a firefighting scenario in which you have to fight 20 meters of flame. It's quite a dangerous task to put for a novice. It's a cost-effective solution. It leverages domains of learning by doing, so it's quite important for learning practical skills. Also, intrinsic engagement nature and the embodied cognition principles allows to have a higher information retention on the long term, and many more. But there are still a lot of open points that are still open to the challenges to be addressed, such as interaction fidelity. We talk a little about that. Multi-user fidelity, which is if you think about scenarios in which multiple people have to coordinate together, so how we teach those people to perform better in a simulated environment, there are subtleties that needs to be considered and going on. Even simple tasks like the locomotion problem, so how you move in a virtual environment that is 100 meters more extended than the room your space that you are available at. And this leads us to another problem, which is commonly as a technology we may be triggered to think that having virtual and augmented reality sharing both the same technology, it means that it's the same building the experience for both of them. But if you think about the locomotion, it's a totally nonsense for an augmented reality application. So technology and design of the experience is quite different, and many more that I will not dig into details right now. I will start to putting you behind the curtain of what happens in this field of research. For instance, by focusing on the interaction aspects in the domain of training, which is brings us to different kind of consideration that we should make. So, for instance, take this scenario in which we have to hypothesize to talk a procedure to a given trainee, and the procedure focus is not actually to, so the procedure use tools such as, in that case, electric screwdrivers and other stuff, but the focus of the procedures is not to learn how to use this tool, how to use the screwdriver, but to learn the procedure. So that means that the interaction with the tool and the other stuff must be as natural as possible, and also as much faithful as possible as in the real world. So, for instance, we can try and evaluate how two different setups, configuration can perform in that case. So, think about the main components of an active feedback. We started showing that in that case, the force feedback and the vibrotactile one, and we bring out two configuration. One in which the two configuration brings with just a single exoskeleton-based force feedback globe, so both feedback in a single device, and another one in which we distributed the feedback on two devices, a much cheaper one globe with just the vibrotactile feedback, and then a 3D printed custom mock-up to simulate the force feedback. Of course, we studied with some people their performance, and eventually we find out that overall, the two configurations were mostly on pair, but the force feedback globe was able to and led to a less usable and more straining experience with respect to the mock-up, but it allowed to better discern among the peculiar sensation associated with the different phasing of the screwing activity. On the other hand, the mock-up provided the user with a higher fidelity in terms of weight and tool shape, which reflected in a superior task accuracy. There was not a clear preference among the two, but as we can see, at a fraction of the cost, we can have a comparable performance with the only downside of having just a custom 3D printed, which is not a minor stuff. If you think we have a visor, an headset that can be reused for multiple VR applications, and then we have a device that sticks to just one. So how we can fix that? We proposed as a proof of concept a reconfigurable approach for tangible interfaces that exploited the Lego-like props to deliver this kind of tangible that mimic the real tools. And the idea here was to, together with the virtual reality training system that we provide and ship to eventually a company and so on, we provide also the instruction and the basic kit to build multiple experiences and also to adapt to the simulation. Virtual reality training systems in general has been there since decades, but nowadays the focus is more on the scalability. So at the core, that means that we want to remove the human instruction from the equation and have the system to be used on a scale by multiple users all over the world, so each one can be self-taught by the system. And this is not exactly the same as having just the simulated environment with a real tutor that instructs you during the simulation. So, of course, if you go to the companies, these are stuff that are already made, but you can get the feedback like VR is cool, we do that in VR without any substantial evidence of that. If you go to the research, this has been proved, but usually in controlled and very laboratorial environment, so we decided to move a step forward in that study. We aggregated a state-of-the-art and implemented a state-of-the-art virtual reality training system for an industrial robotic training scenario, and went to a real training facility where people usually are taught by spending €1,000 on a very well structured and let's say proved system, learning system, and we compared the two groups. So basically, we have done what has been found in the last year of research as better as we could, and found out how that compared to the real world. Both people, so both group of people were tested afterwards on the real robot. So think about that. The results that you will see, people will evaluate for the first time, they will see a robot on that. So it's quite also an emotional experience for them. And we'll see that the effectiveness is quite comparable in terms of ultimate results on the evaluation sheet, but the virtual reality was able to provide that with 3 times shorter time, which is quite astonishing result. Also for us was still quite to see that. Of course, there are some drawbacks. This condensed the training can raise the stress level a little bit more, so but still in an acceptable way. And let's say the fact that the system are not already able to adapt to the different personalities of the trainees can, for some people, be staggering. And moving a bit deeper on that. So this is the general framework of testing a virtual reality training system, but what can be done? Actually, details matter a lot. Details matter a lot, and think about, let's say, we have this plant here, the yellow and red plant, okay? And the trainee wants me to point laser that plant in a given way. So let's say I try to do that. But let's say that if I'm not instructed diversely, I can do that from multiple perspectives. Okay. But if this machine has a particular configuration that I want to instruct people, maybe the trainer wants me to go like that. Okay. So this is not. It can seem easy, but of course you can do with people and say, okay, you are in the wrong position, you are in the wrong position, pop up error messages all over the world, but you will land in an unpleasant training experience. So this combines with the fact that in VR some users tend to behave quite lazy and are not willing to assume uncomfortable head poses without any reason. So we moved from the standard approach of using video instruction and propose another metaphors and approaches for that kind of, to solve this problem, one based on an avatar and one on a full screen visualization. And we eventually find that the standard solution that is usually provided is quite ineffective by means of quite large effect size. So in the end, these are the kind of consideration that experienced designers that work with that technology should consider when designing. So a very little change in your experience, a very little decision can make a whole difference on a difference on the training effectiveness itself. So not something I would also like to give this just a brief overview of that work. Since now we have seen, let's say, the natural translation of a standard training approach, which people are scaffolded, so are guided step by step through the training. So each step you do that, I tell you what to do next, and so on. But there is it's all that. There is nothing more that we can do with such a fancy technology and media. Well, there is many more that we can do. There are many pedagogical models that can be exploited. So even if by having the same technology, the same, let's say, almost the same experience, the way you use that as a trainee can make a lot of difference on the pupils. And we found out, for instance, that learning by teaching approach, we basically use the, in that case, a special augmented reality set up with an autonomous robot that assumes the role as a peer student that you have to taught something. We found out that this interaction boosted quite significantly the effectiveness of the training, but more importantly on the long term. So the same application, the same let's say scenario, not such a different configuration on the simulated scenario, and we have just by changing the way you use that quite a significant improvement. So this is can give you an idea of what happens behind how these are measured and how we make assumption, how we pass these skills to the industry and to the rest of the world. Okay, and finally, just to conclude, briefly summarize what we have seen. So immersive media are truly promising for training education, if any proofs needs to be done eventually. And immersive VR technology is acceptably mature. So, of course, you are maybe the most of your technology you want to get higher resolution displays, sub-millimeter tracking accuracy, and so on and so forth. But actually, what we have right now is already good enough to make a wonderful experience. So there is a need to focus on human-machine interaction aspect and the user experience as well. And details matters a lot in that case. So little changes can make a lot of difference on the results, and of course the best is it. Thank you. And this concludes if you like to see some videos of my activities, I can put that in a slide to not get you distracted too much, but you can access here, and also my list of